Welcome back. As part of the Think Cloud initiative, we have identified five paradigms that would help us in designing cloud-centric system. In this part of the series, we'll be talking about communication. Let's begin by understanding the difference between monolithic and microservice architecture in terms of communication. In a monolithic application, components invoke one another via language level method or function calls. In contrast, a microservice based application, each service instance is typically a separate process. Therefore, they communicate via some RPC mechanism. These service instances may even be running on multiple machines. Let's take a look at cab booking example. A passenger requests for a cab via a smartphone. This request goes to a trip management service, which then verifies that the passenger account is active by sending a request to the passenger management service. Once the account is verified, the trip management service creates a trip and notifies other services, including the dispatcher, which locates an available driver. Once the driver is allocated, a notification is sent to the passenger about the same. In the given example, the trip management needs to wait for a response from the passenger management service before doing the next task. Such communication is called synchronous communication. In contrast, the trip management service creates a trip and notifies the dispatcher service about the same. It doesn't wait for any response from dispatcher service. Such a communication is called asynchronous communication. Now let's dig a little deeper into synchronous communication. Naturally, synchronous communication is arranged as a cycle and requires every microservice in the cycle to work in order. The most popular implementation of synchronous communication is via REST. What is REST? REST or representational state transfer is an architectural style for providing standards between computer systems on the web, making it easier for the system to communicate with each other. A key concept in REST is resource, which typically represents a business object such as a customer or a product or a collection of business objects. REST almost always uses HTTP. REST uses the HTTP verbs for manipulating resources which are referenced using a URL. There are four basic HTTP verbs: post, which creates a new resource; get, which retrieves a specific resource by a collection or a collection of resource; put, which updates a specific resource by the ID; delete, which deletes a specific resource by ID. Now let's go back and take a look at cab booking example and how some of it can be implemented via REST. The client will send a post request to the trip management service. The trip management service will in turn send a get request to passenger management service to get the passenger data. Once the trip management service receives a valid response from the passenger management service, it creates a new trip and sends a response back to the client. The important thing to note here is that the order of communication is very important. So, what are the benefits of REST? HTTP is simple and familiar. You can easily test an HTTP API from within a browser or using an extension such as Postman. HTTP is of course firewall friendly. It does not require an intermediate broker, which simplifies the system architecture. There are some drawbacks of using REST too. It only supports the request response type of interaction. You can use HTTP for notification, but the server must always send an HTTP response. Because the client and service communicate directly, they must be running for the entire duration of the exchange. Now let's dig a little deeper into the interaction style, that is asynchronous communication. Here the message is exchanged asynchronously. Client does not wait for a response. Order of communication is not important. A message consists of header and a message body. Messages are exchanged over channels. There can be multiple producer and consumer of a channel. There are two kinds of channel. The first asynchronous interaction style is one-to-one, where the channel delivers a message to exactly one of the consumer is reading from the channel. This kind of channel is called point-to-point channel. Next, asynchronous interaction style is one-to-many, where the channel delivers each message to all the attached consumers. This kind of channel is called publish-subscribe channel. It has one input channel that splits into multiple output channels, one for each subscriber. Each output channel has only one subscriber, which is only allowed to consume a message once. In this way, each subscriber only gets the message once and consumed copies disappear from the channels. Now let's take a look at an example. Here the trip management service notifies interested services such as dispatcher about a new trip by writing a trip created message to publish subscribe channel. The dispatcher finds an available driver and notifies other services by writing a driver proposed message to publish subscribe channel. So what are the benefits of asynchronous communication? It decouples a client from service. A client makes a request simply by sending a message to the appropriate channel. The client is completely unaware of the service instances. It does not need to use a discovery mechanism to determine the location of a service instance. Message buffering. With a synchronous request response protocol such as a HTTP, both the client and service must be available for the duration of the exchange. In contrast, a message broker queues up the messages written to a channel until they can be processed by the consumer. This means, for example, that an online store can accept orders from customers even when the order fulfillment system is slow or unavailable. Flexible client service interaction. Messaging supports all of the interaction styles described earlier. That is, both one-to-one and one-to-many interaction are supported. There are, however, some downsides to asynchronous messaging. Additional operational complexity. The messaging system is yet another system component that must be installed, configured, and operated. It is essential that the message broker be highly available, otherwise system reliability is impacted. Complexity of implementation. Each request message must contain a reply channel identifier and a correlation identifier. The services writes a response message containing the correlation ID to the reply channel. The client uses the correlation ID to match the response with the request. All this increases the complexity of the implementation. So what did we learn? We learned how communication is different between a monolithic and a microservice architecture. We also looked at various synchronous and asynchronous communication style for microservice architecture. Thank you for listening. Please reach out to us in case of any questions or comments.